Okay, so in this video, we are doing lesson 4.1 and we are starting with bell work. So this should just be for second hour because I am gone on Thursday. So you're going to be doing this bell work question, then you're going to be doing 4.1. I know this is a new notes packet, kind of weird. We're actually disregarding the other notes packet. If you want to recycle it, you can. We found a better notes packet, and so we're going to be starting a new unit, Unit 4, to follow up that quiz that we took earlier this week. Okay, so kind of weird, but this is your new note packet, and this is the packet that we will be quizzing over before Thanksgiving break. So this is the bell work question. It says draw a picture for each description. So I want you to draw complementary angles that are adjacent, and then I want you to draw supplementary angles that are not adjacent. So go ahead, pause this video, write down the bell work, go through, answer those on your bell work sheet, and then you can check with me in a second. Okay, so let's take a look at these. First, I need complementary angles that are adjacent. So complementary angles are angles that add up to 90 degrees. And then adjacent means that they share a side and a vertex. So I need two angles that add up to 90 degrees, also share a side and vertex. So I'm going to create a 90-degree angle. And then the easiest way to do this is just to take that 90-degree angle and to divide it into two parts. So I can call this angle A, angle B. Since that overall angle is 90 degrees, but angle A and angle B also share a vertex and a side, that would match that situation. So that's a set of complementary angles that are adjacent. Next, I can do supplementary angles that are not adjacent. So these need to be two angles that add up to 180 degrees, but they cannot share a side or a vertex. And so what I like to do for this is kind of imagine what would a straight line look like and then break that into two separate angles. So kind of make it so that they're touching, but they're not. So they're not adjacent, but they are two angles that look like they would add up to 180 degrees. So that would be C and D. If you wanted to make this, even more rock solid, you could go through and you could give these angle measures. So you could say 50 degrees and 40 degrees for the complementary angles, and then you could say like 30 degrees and 150 degrees for the supplementary angles. So there are a lot of ways to do that bell work. Make sure you have something similar to what I have. All right, then we are going to get started on 4.1. So again, this is the new note packet we're working on. It's 4.1. We're just kind of getting rid of the other one. We were going to do that, but this one's better. And we decided, you know what, it was worth it to switch over. So we're talking about pairs of lines and angles. I will say the review that we did in that other note packet is very well suited to this. So we've already been talking about angles and things that we remember about angles, which is going to feed into this lesson really well. So the objective is, I know if a pair of lines is one of the following: parallel, intersecting, coincidental, or skew. So that is our main objective for this. As we go through, adding different types of lines together and then talking about the angles that are created as a result. So first, try to do that review question on your own. It says, in the figure, two parallel lines are intersected by a third line called a transversal. So we have two lines. We can call this line M. Sorry, I can do a better M. And line N. They're intersected by a transversal, and that is a term we're going to see a lot kind of throughout this unit. But we are trying to identify a couple things. First, we want to identify all pairs of vertical angles. Remember, those are our bow tie angles. And then we want to identify all linear pairs. Those are the ones that share a side and a vertex. Okay, so again, this is a review. If you want to pause, you can, but find all vertical angles and then all linear pairs. So first off, the vertical angles are going to be a little bit faster than the linear pairs. Those vertical angles are the bow tie angles. They're always across from each other. So we could have angle 1 and angle 3. angle 2 and angle 4. angle 5 and angle 7, and angle 6 and angle 8. So those would be all of the vertical angles. Now the linear pairs are a little bit trickier because linear pairs are any angles that share a vertex and a side. Okay, they're always actually supplementary as well. So we could do angle 1 and 4. But you could also do angle 1 and angle 2. And then you can kind of work your way around. So 1 and 4, 1 and 2. Then I can do angle 2 and angle 3, and angle 3 and angle 4. So lots of different linear pairs, even just on that first intersection. And then I can do the same thing for that second one. So I can say, okay, I see that angle 5 and angle 8 are a linear pair. But then I can also do angle 5 and angle 6, angle 6 and angle 7, and angle 7 and angle 8. So a lot of different angles that can make up those different pairs. Okay, so that was a little bit of a review. Now we're going to be doing some new vocabulary. So we have some new terms. Again, some of these are going to seem familiar because you've seen something like them before, but others are going to be brand new. So we're going to fill out this table and then we will be answering questions about each. So first we're talking about parallel lines. That is definitely a review concept, something that you've seen before, but parallel lines are here's the definition. Two lines are parallel when they do not intersect, and they are coplanar. So if you have two parallel lines, they're on the same plane and they never intersect each other. And we've actually seen this before. You've definitely seen this in 8th grade, I would say. If you have two lines, the way we denote them as parallel is we put little triangles on them going the same direction. So if you want to write that in, the triangle means parallel. And again, they just don't run into each other. So we often talk about train tracks as a way of remembering these because they're never going to intersect. Now, skew lines are a little bit different. So two lines are skew when they do not intersect. Okay, so that same idea of an intersection is important with skew lines, but they are also not coplanar or parallel. And so what I would imagine for skew lines is picture kind of a Kleenex box. So sort of a 3D Kleenex box, and I'll do my best to draw this in because skew lines are a little tricky. Let me do that in dashed because it's technically behind the figure. So say I had a 3D Kleenex box. The only kind I deal with are 3D ones. Okay, it looks something like this. Again, 3D drawing, I could work on that. Let's make these solid because they're on the outside. Okay, so this is a 3D Kleenex box, right? So skew lines would be like one line going left to right on the front, and then having another line like along the back corner going a different direction. So skew lines are kind of weird. You'd have like one on one plane going one way, and then you'd have another line on another plane going another way. So they're not parallel to each other. They're on different planes, but they also don't intersect. So they're skew. So very kind of a strange concept there, but hopefully that'll make more sense kind of as we work through and if you see it in context. Intersecting lines, review. Two lines are intersecting when they have exactly one point in common. Again, we've seen these before. Anytime you have two lines that run into each other at a single point, they intersect, and the intersection is the point they're running into each other at. Coincident lines is something else we've actually seen before. You might not have heard this term, but two lines are coincident lines. When they intersect at infinitely many points, they are the same line. So that's just another term for lines on top of each other, coincident lines. And the way we draw that, everybody kind of draws it differently. I draw basically a line with two sets of arrows to show that they're the same line on top of each other. And then lastly is parallel planes. That's when two planes do not intersect. So literally you have a plane, and remember how we draw planes, they're sort of off to the side. You have one plane and then it's like hovering over another plane. So like the floor and the ceiling are an example of planes that do not intersect because they don't run into each other. So something like that for that picture. So let's use this table to help us, and we're going to answer some questions on that last example. So it says lines blank and blank are parallel lines. Well, based off the picture, the lines that are parallel would be lines M and N. So line M and line N. Lines blank and blank are skew lines. So again, skew lines don't touch each other, they don't intersect, and they're not parallel. So that would be K and M. K and M. And then we need lines that are intersecting lines. So those are two lines that run into each other at a certain point. So that is going to be K and N. K and N. And then lastly, I need the parallel planes. Well, those are going to be the two planes that do not run into each other. So that's going to be T and U. T and U. Now I did want to note some notation things as well. So for example, when I say that M and N are parallel and then there's these little asterisks, it's because I wanted to show you the notation. So if I wanted to write out that lines M and N are parallel, I'd write line M is parallel. It's like two vertical lines to line N. So just in case you need that notation, that is for parallel. And we can also use that for planes, although it's a bit kind of clunky and awkward. We can say plane T is parallel to plane U. Plane T is parallel to plane U. So again, this just means parallel. If you see that, that's just a notation telling you that you have something is parallel to something else. All right, let's keep practicing this vocabulary. So again, we have some new terms. We're just doing examples related to them. So in this next section, it says, think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? Okay, so we're told line or lines parallel to CD and containing point A. So I need to find a line or lines that are parallel to CD. So here's CD, but they also have to contain point A. So as I'm looking for point A, it's right here. So I need to find another line that's parallel to that line, but also includes point A. So it looks to me like that's going to be line segment AB. Line segment AB. We could also call that line AB. It did ask me for the line. AB is a segment of that line. It doesn't have arrows though, so I'd probably accept either one. Next, we're trying to find a line or lines that are skew to CD. So here's CD, that same one we started with before. And they contain point A. So a line that would be skew but also contain point A would be the line AH. Again, they're not parallel, they're on different planes, and they don't run into each other. So that would be that one. Line, again, we could say segment AH. Technically, it doesn't have arrows. Or if we wanted to assume that it's going to go on forever, I can call that line AH. But again, the skew ones are hard. So skew, they don't intersect. They're on different planes. They're kind of wonky. They never get close to each other. Next, we are asked to find lines that are perpendicular to CD and containing point A. So perpendicular to CD containing point A, that means intersecting at a 90-degree angle. And what's nice is Actually, on our picture, we have a 90-degree angle labeled right here. So the line that is perpendicular to CD and contains point A would be line AD. Let me get the right color. Again, you could also call that segment AD. Either way, it does ask for the line, but it doesn't have arrows, so whatever you want. And then lastly, planes that are parallel to EFG and containing point A. So EFG is this plane down here, kind of this bottom surface of that box. So I want a plane that is parallel to EFG, sorry guys, parallel to EFG and containing point A. That would be this top plane. It's parallel, but it also contains point A, and we could call that a variety of things. I'm going to call that plane, and then you just pick 3 points on it. So ABC. Plane ABC. You could also call it CDA or DAB, a variety of things. All right, now that we've practiced those new terms, we are going to add a little bit more, okay, which is parallel postulate. So we're going to talk about the parallel postulate and the perpendicular postulate, okay? Postulates are just mathematical truths. So if you are confused on what a postulate is, it's just something that is true in mathematical truth. And basically, people discover these postulates, and then the rest of us, as amateur mathematicians, use them. So a mathematician said, hey, this is definitely true, and then the rest of us just use that. So the parallel postulate says if there is a line and a point not on the line, then there is exactly one line through that point that is parallel to the given line. And that is shown in the diagram on the right. So if we have a line and a point that's not on the line, so say I have line L, and then I had point P just hanging out, okay, there is only one line that can go through point P and also be parallel to line L. Okay, so the red line would be the only option for that, and that's just the parallel postulate. Versus the perpendicular postulate says if there is a line and a point not on the line, so again, start with line L and we have point P, then there is exactly one line through the point that is perpendicular to the given line. So again, there's only one possible point. I'm sorry, I forgot a U. There's only one possible line that can go through P and be perpendicular to line L. And so we can use, what we've been practicing vocab-wise with those new postulates that can help us on this next problem. So it says, the given line markings show how the roads in a town are related to one another. Okay? It says, name the line parallel to EF that goes through point M. So I need a line parallel to EF, so let's get that on my graph. Here's EF. A line parallel to that goes through point M. So again, the parallel postulate says there's only going to be one line that can do that, one single line that can go through M and also be parallel to EF, and that is going to be line DM. Line DM. Then the next question says, name the line perpendicular to DM that goes through point M. Okay, so we need a line that is perpendicular to this that goes through point M. Now there's only one line like this, but we have different names for it just because of kind of how this is situated on the graph. So we could call this line BF, or line BM, or line MB, those are the same, or line FM. So there's kind of a bunch of different ways to name it, but again, it's just that one that I have highlighted in that sort of coral color. That is the only line or street that goes through point M and is also perpendicular to DM. And then we're going to do one last sort of term, and then we're going to talk about some angles. So another key concept, and this is a big one that we're going to see a lot, is transversal. So a transversal is a line that intersects two or more coplanar lines at different points. So typically the way we see this is we have two parallel lines. They're cut by a transversal. And what's cool about this is a lot of different angle relationships are formed. So we are going to be seeing transversals cutting parallel lines for like the rest of the unit. But again, that transversal is the line that is cutting through two others. So if you have two lines on a graph and you draw a line through them, you would call that the transversal. So let's see the angles that are formed with transversals. First type of angle we have from transversals cutting two lines is corresponding angles. These are two angles are corresponding angles when they have corresponding positions. For example, angle 2 and angle 6 both above the lines and to the right of the transversal, so they're corresponding angles. So again, if we focus on these intersections, I have two places that transversal is cut through those lines. They have the same relative position, so they're both to the right of the transversal and above the line that transversal was intersecting. Okay, so again, this is just some new vocab we're going to see, referring to angles that are cut by a transversal. Okay, that's different from alternate interior angles. So alternate interior angles I'll do in another color. Two angles are alternate interior when they lie inside the two lines and on opposite sides of the transversal. So if you have a transversal, and let me highlight this transversal because the transversal is the key to all of these angle relationships. So say I have a transversal that is cutting two lines. These lines would be alternate interior because they're inside the two lines that were cut. They're on alternate sides of the transversal. So they're called alternate interior because they're inside the lines that were cut by the transversal. They're on opposite sides. Then we have alternate exterior angles. Alternate exterior angles. Two angles are alternate exterior when they lie outside the two lines and on opposite sides of the transversal. So now we have angles that are outside the two lines that were cut with the transversal, and they're still on alternate sides of that transversal. So they're outside and they're on alternate sides of the transversal. And then last but not least, we have consecutive or same side interior angles. Two angles are consecutive angles when they lie inside the two lines cut by the transversal and on the same side of the transversal T. So again, in this situation, these angles are inside the two lines, but they're on the same side of the transversal. I know that sounds like a lot, but here's the deal. You're gonna get this vocab down more from practice than from writing it down. So if you have these as a reference, that's awesome. You're gonna learn this better as we practice. So on number 7, I want to identify all pairs of angles of the given type. So I want to find all corresponding angles. So corresponding angles, if you look at these intersections, they are angles that are in the same relative position. corresponding angles are in the same relative position. So examples of corresponding angles would be like angle 2 and angle 6. Why? Because they're corresponding. They're in the same spot on two different intersections. And again, let's label my transversal is cutting two different lines. So I have two lines and then a transversal cutting through them. So we're comparing those intersections. So angle 2 and angle 6. We could also do angle 1 and angle 5 are corresponding. Angle 3 and angle 7 are corresponding. And angle 4 and angle 8 are corresponding. So those are all examples of corresponding angles on that diagram. Alternate interior angles. So alternate interiors are going to be on the inside. That's missing an N. I'm missing some letters today. Inside. Okay, and then they have to be on alternate sides of the transversal. So we could do 2 and 7, angle 2 and angle 7. You could also do angle 4 and angle 5. So they're alternate interior angles. They're inside the two lines that were cut by the transversal. They're on opposite sides of the transversal. Alternate exterior angles are on the outside. That's the exterior of those two lines. And again, they're on opposite sides. So we could do angle 4. Oh, wait, sorry. Angle 1 and angle 8. You could also do angle 3 and angle 6 as your alternate exterior angles. And then last but not least, consecutive interior angles. Well, those have to be on the inside, but they're on the same side of the transversal. So an example of that would be like angle 4 and angle 7. You could also do angle 2 and angle 5. So sort of as a, last minute check, try to do number 11 on your own. Pause the video, see if you can identify what types of angles are numbered, and then you can go over those with me. So again, pause the video, try these on your own. Okay, so the first two angles, angle 1 and 5 for example A, they're corresponding. They're in the same position on two different intersections. Example B, those are alternate exterior. They're outside the lines that are being cut by the transversal, and they're on opposite sides of the transversal. And then letter C would be alternate interior angles. So I know we did a lot today, and I know you did these with a video. Good thing is you can have this video and go back if there's something you're confused on. I can also answer questions, so you can just let me know. But that was 4.1. You're now going to be working on a homework assignment. You can use the options board. There's definitely a worksheet on the front table though. And then you can also do the extra credit assignment if you have time to do so. I'll see you guys later. Have a good one.